Hello everyone. So let us begin introduction to big data. Let us see what is big data and how it differs from traditional data processing. Then let us understand big data, traditional data processing, limitations of traditional data processing, key differences between them, and big data technologies for processing. So what is big data and how does it differ from traditional data processing? As the name suggests, big data. It refers to extremely large data sets that are complex, fast growing, and generated from various sources such as social media platforms, sensors and IoT devices, online transactions, multimedia content. These data sets are typically too vast and varied to be handled by traditional data processing methods. So what we can say is big data refers to massive complex data sets that are difficult to manage and analyze using traditional data processing tools. It also deals with structured, unstructured or semi-structured data. This typically is 5 V's of big data. Namely, they are volume, velocity, variety, veracity and value. So first one is volume. As we are dealing with big data, we can see that it aims at the very volume of data that makes it terabytes, exabytes and even more in some cases. This is due to continuous increase in the data from different sources such as the social media and the websites and all such sources. Next is the velocity. It refers to the rate at which information is created and analyzed, or a decision is made, or the speed at which a solution is being preferred. Next is variety. The different types of data formats including structured data like databases, unstructured data like text, images, videos, and semi-structured data such as XML or JSON files. So it is nothing but big data has structured, semi-structured and unstructured information, and data sources include any kind of information which can be textual, then in form of image, in form of video or sensor data. Next is veracity. The accuracy and trustworthiness of data are crucial. Big data often comes from multiple sources, making it challenging to ensure its quality. And the last one is the value. That is the ultimate goal of big data is to extract valuable insights that can drive business decisions and strategies. So why is big data important? So big data is important because it provides businesses and organizations with the ability to analyze vast amounts of information, leading to better decision making, improved efficiency and new opportunities for growth and innovation. It helps understand customer behavior, predict trends and optimize operations, ultimately driving better outcomes across various sectors. It can give us data-driven decisions, that is, businesses can make more informed decisions based on concrete data rather than their intuition or gut feelings, leading to more effective strategies and tactics. Then we have improved efficiency, then enhanced consumer or customer experience. That's because we can have decisions based on the data that is available and based on their experience. And next is competitive advantage, that is businesses can have obviously competitive advantage because they have done the decisions themselves. Traditional data processing, so it relies on structured data, that is rows and columns in relational databases. It uses conventional DBMS tools, for example MySQL, Oracle. It is suitable for small to medium data sets. It involves consistent intentional input from known sources. Now big data technologies for processing. First one is batch processing. Next is stream processing, data analysis technique, scalability and parallel processing, data integration and ETL, cloud computing and visualization tools. So in batch processing, processes data in predefined batches or chunks suitable for offline analysis and historical data. Tools such as Hadoop MapReduce, Apache Spark. Use cases: analyzing historical sales data, batch ETL processes. Stream processing analyzes data in real time as it arrives, often used for monitoring alerts and rapid decision making. Tools such as Apache Kafka, Apache Flink. Data analysis technique, machine learning, data mining and visualization. Scalability and parallel processing. Big data tools need to handle vast amounts of data, often by adding more resources or nodes to distribute processing tasks. Techniques such as distributed systems, Hadoop, Spark, and cloud-based solutions. Data integration and ETL involves collecting data from various sources, cleaning, transforming, and loading it into a central repository. Tools, various ETL tools, data warehouses, and cloud-based data platforms. Cloud computing leverages cloud infrastructure for storage, processing, and analysis of big data, offering scalability, cost effectiveness, and flexibility. Platforms such as Google BigQuery, Amazon Redshift, and visualization tools used to present data in visual format to facilitate understanding and decision making. Tools, Tableau and Power BI. These are the key differences between big data and traditional data processing. With respect to data type, in traditional data processing, it is structured. In big data processing, it can be structured, semi-structured, or unstructured. Tools, RDBMS in traditional data processing, Hadoop, Spark, NoSQL, etc. in big data processing. Volumes of data, as you can see. Processing speed moderate in traditional data processing, and in big data processing it is real time or near real time. Scalability limited in traditional data processing, and big data processing highly scalable distributed systems. Thank you.